start from something common for this conference. Those of you that were in the room knows that there's a Jagmeister uh, event happening in here, so we're choosing greatest speakers from Jag. Piotr Limanowski, that was speaking here before me, is part of it. Go and vote for those guys. It will be a great help from your side. So, with that cleared, let's move to the talk. I will try to make it quite brief. I want to have some discussion in the very end because I believe that most of you are refactoring or not. We'll check it in a minute. I also know that I could talk for hours, but there's lunch after it, so I'm not going to hold you in here. I want to live the day. So first, the rules of the talk. If you have any questions, raise your hand right away. I don't mind being interrupted. That's fine for me. If you have any questions, I'll be here also later during the day, till the very, very end. If you need to grab me, I'm on Twitter, LinkedIn, I'm running the Java user group in Tri-City, so it's quite easy to get at me. My blog is being migrated to GitHub pages, I finally decided, but it's not there yet, it's really outdated, but you can find context to me also there. And that's probably it that you need to know about me. I'm the guy who writes code sometimes. So, let's check something about you. Who's refactoring the code? Hands up. Good. On daily basis, keep your hand up if you're doing that on daily basis. And raise your hand if you're planning what you're going to refactor at the beginning of a sprint. There's like 3, 4, 5, let's say that 15 people out of the room. Okay, that's more what I'm used to, and that's what's most common. Because most of the people that I met never were planning what they are going to do as a refactoring. There is a common trend that we go and say to our managers, we need to refactor. And what the heck even that means? So for them, it's mostly gibberish. And I want to talk a bit about what refactoring is, how we do it, why we do it, and how to convince the people with money that allows us to do it. What are the secret techniques and what are my cases where it either went well or failed. But let's start from the basics. So we are going to talk in the same language. Refactoring, let's base it on Fowler. Fowler is like the granddad of refactoring. He's the ultimate source. So refactoring is changing the code without changing the observable behavior. That's probably normal for us, but that's probably the part that the business guys are getting lost. Why the heck you're going to change the code if that changes nothing? Well, we need to, right? We understand it. I won't go deeper into that. My definition for the whole talk will be that refactoring means that you have tests. Otherwise, you're just changing the code. It's not refactoring. If you don't have something that will back you up and tell you that this is how the application should be working, you're just hoping. You're really hoping that it will work in the end in the same way. And by that definition, most of your non-functional requirements, like how fast the application is working, probably are going into the bucket of refactoring. And that eases us how to sell it to the business. And let's talk about it later. But first, the reasons why we refactor our code. So, most likely because it's hard to maintain. You enter the IDE and then you don't really understand. Maybe there's a domain change because you were doing one thing and right now the business shifts to something totally different or a slightly different and you just need to update all of your code base. Or you need a new functionality that really does not fit anyway into existing code base. Maybe there are no tests. Today, we talked with Pavel Schulz in the morning. He does not believe me. I know that a lot of you may also not believe me, but there are projects in this world where you have no tests at all, because no one heard about testing. So that's a good point to refactor. Also, maybe it's just slow to refactor, or the most basic reason is that you get out of the bed in the morning. You want just to get out back there when you think to yourself, I need to go there. I need to see at that piece of, But in the end, maybe it's just you. Maybe you're just biased. Maybe you just went to a conference, saw something cool, and it's not really that it's so bad. But if your friends also don't want to work with it. If your new joiners look like that when they open the IDE for the first time, that's probably a good sign that you need to refactor. Okay, let's start with the definitions, because we separate refactorings into a couple of buckets. The most basic one is everyday refactorings. And by definition of Mariusz Sieraczkiewicz, who's also speaking at this conference today, the last talk, he gives it as basically all of the actions that your IDE can support you. It's all of the things that most likely you're not planning. You're just going through the code and improving slightly the design, fixing the names of the variables to something more meaningful, maybe fixing the methods, maybe extracting something. You're just doing all of the actions. You know the 3 keystrokes for everything, and it just happens. That's basically it. The advantages of that stuff is that it's really, really safe. Why? Because the tools know how to do it. You're not just hoping that in Emacs you will fix it properly. Sorry, Piotr, if you're here. But you're just relying on a tool that knows how to do it. Then you have a set of tests that will prove to you that, yeah, you just did it right. So usually it's super safe, it's super easy, it's super fast. That's the part that we are just doing, but not always. If you got a big bowl of maths, then watch out. For example, my project, we're concatenating a bunch of strings into a class name. Okay, right now it's us, but we inherited the code. We don't really know what to do about it. We're gradually trying to fix it. But the guys were building out of the single letters names of classes and the methods just to use reflection. You find code like that. So watch out, it's not always safe. So small funky bugs may happen, and there's another issue. If you don't have a process for doing something, a lot of people won't do it. So maybe you want to improve your code. Maybe your colleagues want to improve it. Still, without some process backing it up, it often can end up in just you trying to fix something, and it's not so good. So on the other hand, if you will tell that to your manager, you may end up in so restrictive environment that it's impossible to introduce any changes, and that's also bad. Okay, the other type, it's big bangs. You know that moment when you march into your project manager, CEO, some kind of a business guy room and tell him, okay, right now I'm just done. I'm not touching the code anymore. I'm writing it from scratch. I believe that most of the people were there or heard a story about that. And basically, you want to kill a system. It's a death. You just throw it away and try again. It allows for a fresh start. That's actually good. Maybe you will introduce new tools like, yeah, let's have a new Spring. Woo! Maybe you will introduce something else. Maybe you will fix a domain model or something. Or maybe you will just have a reason to change it up. Yay. Also valid reason. Not the best for the company or your friends. That's why we avoid it. But usually you end up like a company from a couple of years ago that gave us Mozilla Firefox, and that was Netscape. If you're using that, you have a serious problem because they are, okay, right now I think that they are back on the market, but back then they tried to do it, they failed. They are one of the best cases to prove that it doesn't work. Why? Because the world moves forward. You got those new so-called business requirements, business values and stuff that tells you, yeah, we're moving forward, there are other companies doing the same thing, so we're just losing. And business is not happy. And if business is not happy and they run out of money, they won't pay to you, you won't finish the project then because you won't work for free, so just don't do it. And even if you will finish the project, no one says that it will work as intended. Okay, so the best advice I can give you, don't do it. Or if you have to, then really, really do it if you're in a situation when there is no turning back point. You've just went to the wall, there's like no one that can tell, we can do something about it. You lost, you're hopeless, that's like the last resort, or you just want to say to everyone that's like almost last resort line to do something about the system and start discussion from that point. Okay, third technique, the one that I prefer, that I will talk mostly later, it's sprouting. It has a couple of names. I think that Fowler calls it strangler or something, strangling refactoring. I think that a couple of other people's also talking about it. I took the name from Michael Feathers. He's a great guy. I really love his talks. Really love his book, Working Effectively with Legacy Code. He gives there in that book a lot of patterns how to work with really outdated code bases. Um, and among many techniques, he introduces something that's called sprouting. You basically take for a new functionality, you take a new offspring of your code, you just put a new seed. You just start writing a new method in a new, clean, tested way. And the old code should be rewiring gradually into the new thing. And one day, you're just going to kill the old code class, whatever, totally. I will argue that you can use it with packages, modules, components, applications, services, microservices, picoservices, something services. You just need to want to do it. It's easy. It's okay. It's not easy. It's simple. It's straightforward. It's testable, and it has a couple of other advantages. So it will allow you to introduce, for example, microservices. Even if you have a monolith, you can have a monolith with services inside, SOA, with some common bus or some other kind of pattern to communicate. You may start extracting those things outside, like in a real microservice way. There's a lot of papers right now, because microservices are a buzzword for like last 3 years. We had a lot of publishing about it. There's a great set of articles, which I really love and always recommend, from SoundCloud. They wrote 3 or 5 blog posts about their use case, how they went from monolith to microservices, what was the reasons, what was the effect, how they went, what tools have they used, and they show you the full way. There are more case studies like that on the web right now. Go and check them, because it's really great tool set for you to think in the future how to do such changes. Okay, dangers. If you will start extracting that like microservices, or you will start gradually introducing changes, and you won't be really thorough with the follow-up of destroying the old code, then you may end up with a huge mess, which will be like unmanageable. So you need a lot of self-discipline. Okay, getting the permissions. So right now, there is also a Mikado method, but I won't go into that. That's like a set of small changes, one after another, and testing them out. But if you want to get permissions, basically you need to start talking like a business does. And business usually talks in terms of the numbers and figures, and we can get them for them. We got like billions of things that we can measure. I just listed out a couple of them. You may show up your speed of how fast you're coding, assuming that commit is more or less always the same among the team. You may say what are the hit regions of the applications. That, come on guys, we are really often when we have bug fixes, amend this part of the application, not the others. We may show them tools like Sonar or something, where you got all of those metrics that are industry standard. And we may even show to them metrics that affect their business, like how many clients can we serve, or how much it will cost to buy a new infrastructure. And while gradually introducing changes, we can show them that the numbers change in our favor, hopefully. If not, then probably we were doing something wrong, and then we at least know that we shouldn't follow the road. So when you measure, you get some metrics, you show some things that are important, and most of them will really allow you to explain to them what you're doing and why it's good. Okay, how to measure? Mentioned Sonar. Sonar is a great tool. It's an industry standard. No one can really argue with you that it's something that you just thought about, because everyone are using Sonar. Or maybe not everyone, but a lot of people. In one tool, you get like billions of metrics. And you got the heat maps, you got there's a plugin that even counts a depth to talk with the same language as they do. It's a first tool to use, in my opinion. It's super easy. Then you got a lot of simple stuff. It doesn't have to be necessarily that tool. I'm not sponsored by any of those things. I just wanted to put a bunch of different metrics. So you can look into your source code repository. You can just bash script. You can just write a bash script that will get you a lot of data out of it. You may use a findbox. You may use some profiler that will tell how fast you're responding. Or prove that before your change and after your change, some metrics just changed. There's also a great source of information, which is people. I know that it sounds crazy that I ask you to go and talk with people, especially from support and QA, but they usually know what is happening in the application. So I haven't been working a lot with support, but I expect that if they will get less calls from the angry clients, then probably it's good. I was working a lot with QA always, and they can provide you with a so-called business justification to do some changes. So for example, you go to them and ask, what's the most common issue for us? And they will tell you a blah. And they got all kind of information. We not always log them in, but they do. And they are quite good about the process. So if you got a lot of problems with module X, they will tell you something is happening with module X. This is the data. Go and fix it. Why? Because they want to do less work. And if we are going to fix it, there's less work for them. And with their help, it's probably you should be able to see it, but basically, this is kind of a matrix. Most of you should know from the web. We need to talk with managers, all kinds of managers, and they usually see us either as those working factory guys or as a big kids, because we go to them and say, hey, I need a new framework. I need it right now. I need like 6 months. And then you don't say why. So with some metrics that we have gathered, we can go to them, sit down, and talk. So if you will explain them why it's good, you may get a permission, because you need to gain trust. If not, then do something on your own. Maybe invest your own time. I'm from economy background. And for example, I've been learning a lot how to invest something to get a bigger return in the end. So maybe just sit down with a team, grab a couple of beer packs, couple of boxes of pizza, and fix some code over the weekend. They are not paying for that. After the first iteration, if you have picked something that's like easily fixable, and you're sure that you estimated it right, you will get a data. And if you have gathered the metrics before and after, you will get the data and you can prove them. Okay, guys, right now in a sprint, we're doing like the velocity is 15. After the change, it's 16. Because you can see it in here on the scale of a time, because some manager is probably gathering all of the data. Look, we did something good. Trust us. We have better ideas. Prove it once or twice, and probably they will just ask you, okay, can we fix something? Building a trust is not an easy thing, especially that we have a long history of failing. But yeah, it can be even fun. Also, I would highly recommend you to set up a process of fixing bugs, like the Boy Scout rules. So tell your managers that we want to deliver the better software, that we want to do a good job, provide them with a sonar, provide them with a DOD, definition of done, say that the Scrum that you're putting on us wants that piece of paper in the project, and we should really bend to that because you want to do it. Just play by their rules. Obfuscate them when you need to do that, but basically bend them to your needs. It's quite easy. It's helping, so I wouldn't mind doing that. Okay, with all of the metrics, you can start showing them. If we are going faster, you're saving money. Because in the end, all of those things that you gathered, less servers, less developers, more features, less bugs, turns out for them to be money. And this is what they really care about. So, show them that you can save money for them, not only get them, and you're golden, because that's how you get trust. Free sources, I don't want to bore you with academia. Let's go to the examples, real-life use cases. Free books that I will highly recommend to you is Fowler, Karievsky, and Feathers. And all of them treat about the topic. I believe that you should read them, especially the Fowler book if you're working with LeJC code. It doesn't have refactoring in its name. It doesn't have anything about testing, and it's, sorry, the weather took its toll. So it doesn't have anything with testing, but it's all about that. It's like software craftsmanship one-on-one from many, many years ago, but it's still valid. Okay, so some examples from my career. Let's explain how I see all kinds of refactorings. The daily refactorings, the basic stuff. Other than having the small things, small amendments on your daily work, I had a project. We did 2 waterfalls, one after another. That was my real first project that someone was paying for. Yay. I was still fresh. We had a really fresh team of guys working on it. And in the first phase, we were building kind of an Excel tool that was used to sort out the packages. And in the first waterfallish period, I created a structure, data structure. It probably looked like that. Maybe it was a bit longer with 1 or 2 maps in between. So it was map of map of map of map with lists in that. And those were like objects that did something. Sounds intuitive, right? Like the best domain model ever. Turns out that not. I was the only person that understood it. And then I thought that I will fix it. I had some time in between of waterfalls, yay. Right now, working in Agile and sprints and continuously working on project, I would probably schedule that as a sprint or half of a sprint. I call it a day refactoring because I did all of the job with IDE. I mastered the tool and did kind of there's an exercise, refactoring golf or code golf, they call it by different names. You basically do a set of changes on a code base using only your IDE shortcuts. You never write a new code. And I removed that horrible thing from most places just by that, just by using a couple of tricks with inlining, extracting, and so on. Introduced a couple of facades, it was better. I then learned what the hell is the leaky abstractions and why I didn't do a good job, but that's like a different story. So you can plan even the daily refactorings if they are big enough, and it's worth it. As for the big bangs and how we proceeded from there, we had a system that was like 5 years old, maybe even more. It was inherited from the company that told us that we should do a work on it. It was a long-running project. And the catch was that their previous CEO, who they fired, was working after hours with his friends by having a beer on that system. They did it for a couple of years. They introduced a couple of their own frameworks, and they asked us to just use it. I wasn't there on the very beginning. I joined the team tad later when the guys started to build something upon it. It was like a public company, so they had to use it. They just couldn't dump it. Things like that happen. So we went for 5 years of building the application. The old code creeped all around, so we had it everywhere. It was unavoidable. So there was, after those 5 years, there was a sudden plan of changes, what they wanted to do. They decided that the business model of company changes. They were a recruitment company. They had people with CVs and employees with job offers in the system, and they were matching them together. And they finally discovered that they don't want neither of those two. They want some agencies that are going to do some work. I wasn't at the project at the moment. I switched the jobs, but they took me in as I was working for a long time there, and they took me as an expert. We said that, yeah, it sounds like adding 2 checkboxes, but it's not. it was our big ball of mud. So by having a lot of meetings, and by that time I understood that meetings are not necessarily the all evil in the world. Uh, we sat down with a client and explained him all of the dependencies in the code, and that's the three checkboxes that he thought about are not really so easy to implement. Uh, we increased the estimation from some hundreds of hours to some 10,000s of hours. The client understood that he won't proceed, that it's a no-go, and then we started to explain him that we can introduce some changes for his business to start rolling over and over and over and over again and go into some direction. But at the very end, we'll have to kill the application and just put a new in its place. And as we were cutting out a lot of weird and funky requirements, it would be working. I don't know where they headed with it, because I even quit the company sometime later. But I know that the application is still alive, and they are doing still changes. So if you're treating a big bang as a start of a discussion, it's not really a problem. But if you will say that there is like no other way around it, then suddenly it can get itchy. Okay, sprouting, something that I also want to talk about. So it's not my system. It's my current system that I am working on. It's almost there. Last year, I tried to run JArchitect on this very machine to get a diagram like that. Sadly, it crashed. It crashed with the whole PC, and it was like, damn. So we have like one server with structure one-on-one installed on it that produces such diagrams. The rule is that you have to RDP into the server. You can look at it. You cannot run it again because it takes like a hell lot of time. So this is what I'm working with, let's say, and this is how I see it. So when you have a system like that, we started to do simple things like identifying those small balls that are there and try to pull them out. We pulled out like 100 couple of modules out of the one monolith system, and this is how far we were able to go. Why? Because the system itself had a couple of God classes that prevented us from splitting it even more. We have a very little set of tests, so we sat down and discussed with a client what we can do, and we decided, and as you may notice, I'm not an architect because my drawings are like awful. We decided that we are going to put the whole mess in a box, put a lot of APIs, facades, and stuff like that around it, write a lot of tests, and then kill the system inside. We are in the process. It's working quite well. And it started with a discussion with a business that we want to pull out one more of those balls out of the whole mess. We said to them, okay, come on. I took a BA into the project. We showed him the project. He identified that there are like a couple of modules that are independent and that there's a piece of application that's an administrative application, user application. All kinds of departments are using that. It's written in Swing and it makes no sense. So we thought that let's pull out some marketing part of the application out of it, give it to marketing. Marketing will pay for it. It's great, yay. We identified it, went to the business. Business said, it makes sense. Let's think about it because we have a lot of projects in marketing. Maybe we can combine the work. They allowed us to do it. And when we got the permission and started to gather requirements, they finally thought, okay, we want to have APIs as well, so maybe we can combine both. So right now we're working only on APIs. Okay, I also mentioned to you go to QA. Out of it, I got a good story because QA and Ops were doing a weekly releases on that huge pile of code. And they were struggling with custom system for the database changes. It's not the most exciting change from the code perspective because it's not like coding, but we still introduce a tool. We didn't change the observable behavior, so I will abuse the definition of refactoring and say that we refactored the process. And right now we introduced a tool called Liquibase. From a couple of people, I don't remember how many exactly, they had to support the release process and then help all of the developers to speed up the development after the release and bring up the database, local database and QA environments into one version. We just got this. It was easier than doing a Docker or something and huge change. And it came out of different departments. It didn't came from developers only. We identified the problem. They said to us, okay, this is what we need. This is what would be really helpful. We went with that to business. They approved. We did the same with versioning. So we introduced the Maven for them because they wanted that. Don't ask why, but it's a long story. And then we started to versioning things. Story is same. Everyone knew that it's bad. Everyone told us that, yeah, please do it, and we did. The pattern in here that you may observe is that usually we are not just going and asking for permission. We usually go and ask others, what are your problems? And then go with a feedback to the business and say, hey, come on, there is like a problem. It's not like something that I want to introduce new library. Or it's not like I want to just be typing on a keyboard for half a day, you don't know what I'm doing, and you're paying for me for that. It's really, really helpful if someone will back you up. That's like the most important message out of this talk, if you will take anything. Okay, last thing. We had a refactoring team, and it didn't go well. I heard about the pattern from many, many companies, and it does not work anywhere. So always complain if someone proposes that. Why? Because you will have only one group of people that care about the code. All other teams, maybe not all others, maybe not all of the team members, but they won't put such a care into having that. You may have a team that's doing that, but each sprint, it should be a different team. Just rotate there. It works. Or just make the process that everyone needs to be refactoring the code whenever they see some issues. For example, if you cannot commit a code, if Sonar tells you that there are some critical issues or the blocking issues or the number of minor issues raised by some number, then it's a pre-commit hook. It doesn't allow you to do that. Introduce a process that will replace one team because it doesn't scale. And it will make your teammates leave. Okay, I think that I mentioned that in the very beginning, I hope, that I don't want to do even questions. If you have questions, ask them, but I hope that other than questions, I will get stories out of you. So if you have any story to share or questions, that's the right time. If not, then you will finish earlier to get for food earlier. But I hope for some good stories, if you want to share something. I don't bite. The lady with microphone does not as well, so. Come on, someone is doing refactoring. Someone had problems. Okay, I take it as a no. Okay, then thank you.